Hello, everyone. Thank you for joining this webinar or viewing this recording. My name is Peter Smith, and I am the CEO and a co-founder of Semaphore Solutions. And today, we will be talking about our LIMS product, Labbit, and how it is designed to handle the key challenges in modern laboratories. I'd first like to thank Asterix for hosting this webinar. Asterix has been a leader in laboratory digital transformation for a long time, and I really appreciate their invitation to present today. I'll be joined later by Megan Bauman, Labbit's Senior Product Manager, who will be demonstrating our AI-driven configuration assistant, an exciting tool that is making implementation accessible to a wide range of users and driving down implementation times. As I mentioned, today I will be focusing on Labbit, our next generation LIMS. But first, let me tell you a bit about Semaphore Solutions, the parent company. Semaphore was founded in 2010 by enterprise software professionals to bring software best practices to enterprise scale challenges. We fully focused on laboratory informatics around 2015, and through this work we formed an opinion about what the next generation of LIMS should look like. We couldn't find anyone in the market really tackling this challenge, and so in 2019 we began developing Labbit. Our first customer, a high complexity, high throughput, FDA accredited lab sequencing whole exomes, went into production with Labbit in 2022. Since then, Labbit has been adopted by small and large molecular diagnostic labs, cell and gene therapy companies, manufacturing quality control labs, and R&D labs. So prior to building Labbit, what were the challenges we and our customers were experiencing with existing products? We observed that informatics is effectively slowing down the delivery of scientific innovation. This has multiple root causes, including long implementation times, delaying time to market, poor change management impeding optimization, and inflexible data models preventing the effective reuse of laboratory-generated data. We believe that informatics should be accelerating the innovation cycle through managing the evolving scientific and business processes that drive the operations of a modern lab. Informatics should fully support compliance and should enable organizations to fully utilize the massive data sets they are collecting. We also found that a significant number of customers, especially the most innovative ones, were electing to build their own custom software because what was available was not flexible or scalable enough. This distracted these organizations from their primary missions, and we wanted to remove this distraction. To summarize the key challenges, labs are grappling with complex and continuously evolving workflows and data sets. It's a workflow plus data problem. Here are Labbit's key architectural features that address the challenges most labs are facing now or will be facing soon. In this talk, I want to dive into why we chose Business Process Model and Notation, BPMN, and the RDF Knowledge Graph, and how Labbit's architecture enables the use of AI from configuration through to data reuse. Before I dive into that, I want to address this question. What is a LIMS? It's an important one because it's a difficult one to answer. The ASTM has a decent definition. This is just one of the three that they provide, but maybe Wikipedia has the most accurate take. The definition of LIMS depends on who you're talking to. Each of the typical stakeholders I've listed here have different concerns, different requirements, different backgrounds, and therefore they have sometimes quite divergent expectations of a LIMS, even within the same organization. The history of LIMS goes back over 30 years, and over time, the technology and processes used in labs have evolved, driving necessary changes in LIMS. The capabilities of LIMS have expanded to the point where this next generation of LIMS needs to be capable of natively managing a wide range of complex workload and varied data sets. But this slide summarizes what is the most important point when discussing LIMS. Different labs have truly different needs and different perspectives on LIMS. It is dangerous to generalize, but we're pretty comfortable with these three main distinctions. Manufacturing quality control. This is what the traditional realm of LIMS, and it's a very big umbrella. Master data is a very key concept. Many analytical assays, many product and sample types to be tested. Molecular diagnostics, it's kind of the opposite. Few assays and few sample types, maybe just one even. Very complex workflows, many steps in those workflows. And it turns out master data is generally not an important concept in this realm. Research and discovery, sample management, experimental design and execution. These are all important aspects. And you begin to get a blurred boundary with electronic lab notebooks in this area. And then there are hybrid labs. For example, cell and gene therapy labs often think about LIMS in the same way as manufacturing QC labs. However, the biological processes involved share complexity with molecular diagnostics. Another important consideration with any integrated software platform is where the boundaries between different systems lie. A significant source of uncertainty in laboratory informatics is what's the boundary between an ELN and a LIMS. ELNs and LIMS will have some clearly defined differences in features and clearly some overlap, but one of the most important differences is varying degree of structure needed by the different types of lab stakeholders. Research and discovery need to be unstructured by nature. That lack of structure, though, can present problems later on during analysis and audit, and in fact, data reuse can be hindered. But post-research, data and process structure become very important. The data structure enhances the value of the recorded data, the searchability and accessibility of that data, and the structure around process enhances the quality of that recorded data, and this is where LIMS are designed to support. So that gives you a picture of what we were thinking about when we started designing Labbit. We were fully focused on creating the best provenance record and data reuse opportunities while providing full workflow and data capture flexibility. I'd like to talk now about how we accomplish these goals. Now, fair data principles are talked a lot about these days, so I won't dive too deeply into the background, but we saw a clear opportunity to embrace FAIR principles when designing Labbit. FAIR may not actually be a priority for many of our customers, but it does provide excellent guidance for creating a data store that supports long-term data value, something which all users care about. So how did FAIR data principles influence the design of Labbit? The primary database for Labbit is an RDF knowledge graph, which is extremely well suited for fulfilling FAIR principles. A knowledge graph database not only captures all the relevant data and metadata, like a SQL database, but it has two key additional features that make it especially useful for LIMS. The relationships between all entities are recorded, leading to a highly accurate and detailed picture of process history. And secondly, knowledge graphs do not require an upfront schema definition, meaning that the database can easily keep up with the pace of change in the lab, and also enable data analysis in the future that is not hindered by choices in schema that were made today. The structure of data in a knowledge graph is guided by ontologies, and we have used an open ontology maintained by the web standards body W3C called Prov-O, which defines the structure of Labbit's provenance records. This ensures our approach to provenance follows best practice guided by years of research and expertise. So the provenance ontology defines how we capture what actually happened during a specific process execution, but how do we define what should happen? We call this prospective provenance, and we use the open standard BPMN to define this. Despite being developed for general business processes, our customers have proven that it works extremely well for complex laboratory processes. In addition to being a very precise way to define workflows in Labbit, BPMN is also an incredible communication tool. Users can draw a process diagram very quickly, and all stakeholders, regardless of IT expertise, can very quickly understand and agree on the LIMS workflow configuration. So after we decided on BPMN for prospective provenance and the knowledge graph for retrospective provenance, and then defined this one-to-one mapping BPMN to the Prov-O ontology, we knew we were on the right track. We had a very elegant way to define laboratory processes and a way to record high-fidelity history. Another piece of the puzzle is the definition of what happens in each of the boxes in the BPMN diagram, what we call the workflow tasks. These tasks can be fully automated, but are usually interactions with laboratory users, and the user interface for each task can be fully configured. The task also defines what data and metadata is stored when the task completes, without requiring a schema. In this way, the data model is completely aligned with the workflow configuration and stays synchronized as workflows evolve. This allows Labbit to keep pace with laboratory innovation. It's not necessary to create any of these workflow diagrams or tasks from scratch, as we have a library of pre-configured workflows and tasks enabling out-of-the-box capabilities for common workflows. And as Megan will demonstrate in a few minutes, we also have an AI-driven configuration assistant to help with workflow and task creation. I'd like to briefly explain how Labbit's design supports both a fully manual implementation process and also the AI-assisted one. Our workflow designer enables users to draw BPMN diagrams and then configure each task with a graphical user interface. However, under the hood, the BPMN and task designs are human and computer readable documents. Large language models are proving to be extremely capable of creating documents from natural language instructions, and our AI configuration assistant is proving to be very capable of creating Labbit configurations. One very interesting and valuable consequence of using a knowledge graph and the W3 ontology is how all this comes together to create a very clean fulfillment of 21 CFR Part 11 compliant electronic records. When a task in a BPMN workflow is completed, a permanent node in the knowledge graph is created, and that forms the electronic record for that task. Note that the record is not assembled from a collection of tables like a SQL-based LIMS would do with a complex SQL query. The data, metadata, e-signatures are all captured with full context and reliably retrieved as a single immutable record. Finally, just before I hand over to Megan, I'd like to explain how we use the knowledge graph to present a provenance or audit record. Here is the history view of a simplified library prep. This is the specific history of a pool, so it starts with the pooling step, and you can see some QC steps before the sequencer run. I'll first show how the knowledge graph allows us to easily get details on a specific step. In this case, I've selected the qubit step, and then I click on the link on the right-hand pane to open up the record of that task execution. What we see here is the data captured in this step, with links that allow us to go deeper. Also, what we're seeing here is the exact configuration in place when this record was created, even if it was created 2 years ago. We believe this full capture of data plus configuration history is necessary to provide a true provenance record. So I'll go back to the pool's history. I've here selected an instance of the pool that is on the flow cell going into the sequencer. On the right-hand pane, I can now click on any one of the constituent samples and see their specific provenance chain. And here we see how that specific sample that I clicked on has its own provenance chain, this one going back to accessioning of the sample and eventually joining up with the pool. So we could spend a lot of time navigating around this run's history. Every link you've seen on the past 4 screens will take you into another aspect of the run's provenance. But this makes clear how the knowledge graph enables a very rich history, a provenance chain or an audit trail of everything happening in the lab. I will now hand over to Megan to demonstrate our AI configuration assistant in action.
Great, thank you, Peter. As Peter outlined, labs today are under pressure to move faster. The pace of scientific innovation is accelerating. Regulatory requirements are evolving, and there's a constant drive to improve processes. Together, these forces drive the need for rapid, iterative change. Historically, even seemingly small change requests to informatics platforms can take time. They often depend on specialized resources or vendor requests. As a result, progress toward change can slow under these bottlenecks. This gap between the pace of change and the pace of informatics is a significant obstacle that labs continue to face. At Labbit, we believe informatics shouldn't be the bottleneck. It should be the accelerator. That's a primary reason why we built the AI-powered configuration assistant. The assistant is designed with 3 key principles in mind. Informatics must adapt at the pace of innovation and change. Platforms must accelerate change, not block it. And configuration must be accessible, not limited to specialists. The assistant transforms plain language, SOPs, or diagrams into executable workflows. It builds connected, traceable configurations automatically. and it enables rapid refinement so workflows evolve as quickly as operational changes. In today's demo, we will start from a natural language description and create a workflow in minutes. We'll refine and update it in real time, and you'll get to see how change can become fast, autonomous, and scalable.
Okay, so we're going to jump into the demo of the configuration assistant. Here we have the interface for the configuration assistant. As you can see, the interface provides guidance to users around not only prompt formation on the left-hand side, but also just general terminology and instruction on the right-hand side. We're going to begin by describing in natural language a workflow or a series of workflows that we would like to build. So in this case, we're going to describe some workflows that will enable a manufacturing QC lab. Here I'm just describing it. Alternatively, you could also upload documents such as requirements documents, diagram documents, PDFs that could also instruct the assistant on what to build. So I've described what I want, and the assistant is going to come back to us with a proposed design for a Labbit environment configuration. So if we take a look here, we can see some of the elements that it's proposing in its design. So it's building out the framework of workflows, nested workflows, tasks, that structure of the workflows within Labbit, but it's also building out the configuration elements within those tasks that will enable this workflow to be executable within Labbit. So some of those components include entity type definition, attributes that make up those entity types, inputs and outputs to tasks. You can see task fields here. We can also see some of the user interface components here, such as an accessioning grid, some task fields, and then it's also suggesting the task transitions. So what happens next to the entities that pass through this task? All of that is being proposed in this design. Now, as the operator defining these workflows, I can further refine the proposed design. I can suggest additional workflows. I can suggest additional tasks, removal of tasks. I can even get pretty granular with the changes that I'm requesting to the design. In this case, I'm going to ask for an additional file field, a file upload field to be added to the initial raw material accessioning task. So I'm going to make that request to the assistant. It's going to process the request and come back with a refined design. Now, let's say that you wanted to make additional changes. You have that opportunity. It's very iterative, and you can almost have a conversation with the assistant to refine your design until it's appropriate for your requirements. Now, in this case, for the purpose of today's demo, I'm going to assume that the proposed design fulfills my requirements, and I'm going to instruct the assistant to deploy these workflows to the Labbit environment. So now what it's doing is calling on a series of agents behind the scenes to build out all those various elements of configuration that we saw in the design. This can take several minutes. For today's demo, we have sped this up, but when you think about the time savings, it's quite significant. This level of configuration to not only build out the framework for workflows and tasks, but then also the configuration that goes into it to make it executable can often take several weeks. In this case, we're condensing that time to several minutes to build this core foundation for us. As it builds out the configuration, the assistant provides updates along the way so that the user knows the status of their workflow configuration. And finally, we get a notification that it has been completed. So let's go check it out in the environment. I'm going to jump into the Labbit environment where this was deployed to. After securely logging in, here I can see all of the workflows that it built out, and each of those boxes represents a task within the workflow. From here, I can review the task configuration. Let's go into the accession raw materials. I can see that it's built out the patterns for my entity types with the defining attributes and fields. On the right-hand side, if we take a look at this preview panel, we can see that it's also built out the UI elements for end users, displaying what end users will see when they come in and interact with this task and workflow. Now, if I want to complete additional updates to the configuration, I'm able to do so through the UI here, or I would be able to go back to the configuration assistant and ask it to make those updates. Depends on the breadth of the change. Sometimes it's quicker if you're in here looking at it to just make the update in here. So as you can see, this can be quite a time savings for building out our system configuration and getting some of that foundational configuration completed. If you would like to see the configuration assistant in action with some of your own workflows, or would like to learn more about Labbit in general, we would love to connect with you directly. Click on the button contained within the slide and select a time from the calendar that would work best for you. Alternatively, just drop us an email at sales@labbit.com and we'd be happy to reach out.